Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 24, 2025, about 2 days ago. It introduces a data-free distillation method called free flow that avoids teacher data mismatch, yet still reaches a Frechet inception distance of 1.45 on ImageNet 256 and 1.49 on ImageNet 512, all with just one sampling step, which is a big deal for fast, high-quality image generation. The paper is titled Flow Map Distillation Without Data, and as we will see later, the implications for accelerating generative models are quite significant. Alright, Figure 1 makes the core motivation very visual. The top row contrasts data-based distillation, where a student learns from noisy versions of a fixed dataset, with the teacher's true trajectory, which may pass through very different intermediate states, so a mismatch appears in the red dashed box. The bottom row instead starts from the prior distribution and follows the teacher's own flow, which guarantees alignment and removes that mismatch by construction. So while Figure 1 contrasted data-based and data-free views conceptually, Figure 2 shows how damaging teacher data mismatch becomes in practice. The top plots depict heavier resolution degradation, which blurs or corrupts training images, and the right-hand curve shows Frechet inception distance shooting up as resolution drops. The bottom row reduces the number of classes, and the corresponding curve reveals that fewer, less representative classes likewise cause FID to spike, so stronger augmentation clearly harms the distilled student. Well, while the previous figure showed how database distortions hurt quality, Table 1 shows which training tweaks actually rescue performance. The left columns reveal that sampling the correction loss more at high noise levels and keeping the full noise range both lower Frechet inception distance substantially. The bottom left block indicates that using a wider guidance interval also helps. The right block shows that, when combining both objectives, stronger decay on the generating velocity gradient yields the best scores. Alright, Table 2 turns from ablations to a head-to-head comparison on ImageNet. The upper block shows teacher models like SIT-XL2 and SIT-XL2 plus REPA, reaching Frechet inception distance around 2.1 and 1.4, but only with hundreds of function evaluations. The middle block lists fast flows trained from scratch that either need many steps or suffer much worse scores. The distillation block shows free flow XL2, matching or beating other distilled models, staying within about 10% of the teacher while using just a single function evaluation. So, while Table 2 focused on ImageNet at 256 resolution, this table reports the same story at 512 by 512. The top block lists powerful teacher models that hit FID between about 1.3 and 2.6, but require dozens or hundreds of function evaluations. The middle rows show fast flows trained from scratch that use only one or a few steps yet have clearly worse FID. The bottom distillation block shows free flow XL2 narrowing that gap, reaching FID about 1.5 from the best teacher with just a single step. Alright, the previous table compared full ImageNet runs, and Table 5 zooms in on how the two training objectives interact. Using only the prediction objective, Equation 9 gives a Frechet inception distance around 5.8. Using only the correction objective, Equation 11 improves this to about 3.2. Combining both objectives cuts Frechet inception distance to about 1.7 and also raises inception score noticeably, showing strong synergy rather than redundancy. So the big picture is that free flow shows you can distill fast, one-step flow models using no training data at all, just the prior, and still match or nearly match heavyweight teachers. That result challenges the assumption that external datasets are necessary for high-fidelity distillation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.